When something breaks in production, pressure goes up. Logs everywhere, alerts firing, people asking for updates. In this video, I will show how AI can help you think clearly during troubleshooting without guessing work. Hi, I am Avinash. This is phase 2, video 4 of our AI learning journey. So far, we learned AI tools, prompting, and documentations. Now let's apply AI where it really matters, problem analysis. This section introduces the presentation topic using AI for troubleshooting and analysis at work and outline the agenda. The agenda includes key areas, why troubleshooting is hard, where AI actually helps, real IT examples, what not to do, and simple troubleshooting workflow. Let's understand the challenges in modern IT troubleshooting. Troubleshooting in modern IT environment is challenging due to several factors. First, systems are highly complex and interconnected, involving multiple layers such as application, network, and cloud services. This complexity creates numerous potential failure points. Second, the sheer volume of logs, alerts, and telemetry data makes manual analysis time consuming and error prone. Third, dependencies between services means that a single issue can cascade across systems, making root cause identification difficult. Additionally, human error. These challenges highlight the need for intelligent tools that can process large data set, identify pattern, and assist in accurate problem resolution. Now we will see AI applications in troubleshooting. AI significantly enhanced troubleshooting by automating data analysis and providing actionable insights. It helps in pattern recognition across massive log files, enabling quick identification of anomalies and recurring issues. Predictive analytics powered by machine learning can forecast potential failure before they occur, reducing downtime. AI driven tools prioritize alert based on severity and impact, ensuring that critical issues receive immediate attention. Natural language processing enable automated interpretation of unstructured logs, while knowledge graphs map dependencies to pinpoint root cause. These capabilities reduce mean time to repair, improve accuracy, and free IT teams from repetitive tasks, allowing them to focus on strategic initiatives. We will go through the case studies of AI in IT operations. Several real-world examples demonstrate AI impact on IT troubleshooting. Tools like Dynatrace Datadog use AI-driven monitoring to detect anomalies and automate incident resolution. In cloud environment, AI assists in predictive scaling and failure prevention, reducing service disruption. Data centers employ AI for predictive maintenance, analyzing sensor data to anticipate power failure, hardware failure. These examples show how AI transform reactive troubleshooting into proactive management, minimizing downtime and improving service reliability. Let's see common pitfalls in AI adoption. While AI offers immense benefit, improper implementation can lead to failures. Blindly trusting AI output without human validation is a major risk, as models can produce incorrect recommendation due to data bias or incomplete training, ignoring data quality issues undermine AI effectiveness, as inaccurate or inconsistent data leads to flawed insights. Over automation without human oversight can result in cascading error, especially in critical systems. AI enabled workflow steps. Let's understand it. A streamlined troubleshooting workflow integrate AI at key stages. Step 1. Collect comprehensive data from logs, metrics, and alerts. Step 2. Use AI assisted analysis to identify pattern anomalies and potential root cause. Step 3. Validate AI findings through human review to ensure accuracy. Step 4. Implement correlative action based on validated insight. Step 5. Feed resolution data back into AI models for continuous learning and implementations. Let's understand the limitation and emerging trends. Despite its advantage, AI in troubleshooting face challenges such as data privacy concern, integration complexity, and model bias. Organizations must address these issues through robust governance and ethical AI practice. Looking ahead, trends like autonomous AI, IT operations, and self healing systems promise to further transform troubleshooting. These advancements aim to create environments where systems automatically detect, diagnose, and resolve issues without human intervention. So the key takeaways are: troubleshooting is quite complex due to interconnected systems and massive data volumes. AI addresses these challenges by automating analysis, predicting failures, and improving accuracy. Real world examples highlight its transformative impact, while warning notes emphasize the need for balanced adoption. A simple AI enhanced workflow ensure efficiency and reliability. In the next video, we will combine everything we have learned so far and apply AI to a real mini task end to end. AI won't replace troubleshooting skills, it improves them. Where do you struggle most, understanding errors or finding next step? Subscribe to continue phase 2, practical AI uses. Thank you.